Hello students, what is going on? मैं अब्दुल्ला मोमिन KMS इंग्लिश मीडियम हाई स्कूल एंड जूनियर कॉलेज। और इस वीडियो में हम सुपरपोजिशन ऑफ वेव्स के क्वेश्चन बैंक सॉल्व करने वाले हैं। So the first question is from very short answer. A wave is represented by the equation y is equal to a sine bx plus ct. Given that constant A, B, and C are positive, can you tell which direction the wave is moving? So if there is a positive sign in between the constant, then the wave is traveling along negative x direction. So the next question is, a 1 meter long string fixed at one end, the other end is moved up and down with frequency 20 Hz. So the length of the string is 1 meter and the frequency is 20 Hz. Due to this, a stationary wave with 4 complete loops gets produced on the string. Find the speed of the progressive wave which produces the stationary wave. Remember that the moving end is antinode. So if a wave is completing 4 complete loop and the moving end is antinode, so one crest and one trough, this distance is lambda. This distance is also lambda, and this distance is lambda by 4. So the total distance is lambda plus lambda by 4. So when you will add this, we will get 9 lambda by 4. This is the length of, so we will write lambda is equal to 4L by 9. And now we have the value of lambda, that is 4L by 9, and the speed is v is equal to n lambda, means 20 into 4L by 9, and the value of L is 1. So 20 into 4 into 1 upon 9. So 80 upon 9, and you will get the answer 9 ones are 9, 9 eights are 72. So 8.83 meter per second, that is the velocity. Next, a stationary wave is set up in the string having both end fixed. What is the ratio of the fundamental frequency to third harmonic? So when a stationary wave is fixed, the first mode is called as fundamental frequency, and the fundamental frequency is 2L root T by M, and the third harmonic, means second overtone, is equal to 3N. So we will write 3 by 2L root T by M. So when you will get, calculate the ratio of these two, this thing and this thing will get cancelled, and we will get the ratio as 1 by 3. Next is a equation of simple harmonic progressive wave is given by y is equal to sine pi by 2, y is equal to sine pi by 2 into 4t upon 0.025 minus x upon 0.25, where all quantities are in SI units. So we need 2 here. The general equation or the standard equation is y is equal to sine 2 pi small t upon capital T minus x upon lambda. So we need 2 pi here. So we are going to multiply this equation by 2 and divide it by 2. So we will get y is equal to sine 2 pi upon 4t upon 0.025 minus x upon 0.25. So 4 gets multiplied here with both the terms. So we will get y is equal to sine 2 pi 4t divided by 4 into 0.025 minus x upon 4 into 0.25. So this 4 and this 4 will get cancelled. 4 into 0.25 means 0.25 means 1. So sine 2 pi is equal to small t upon 0.025 minus x upon 1. So this is our equation 2, and this standard equation is equation 1. Now we will compare these two equations. Comparing equation 1 and equation 2, we get, so instead of t we have 0.025 seconds. So we will write the time period is 0.02 and the reciprocal of time period is frequency. And lambda is equal to 1 meter. So frequency is equal to 1 by t means 1 upon 0.025. So we will get 40 hertz. Amplitude, so instead of amplitude, this is your amplitude. Amplitude is 1 meter. So this is wavelength 1 meter. This is amplitude. Frequency is 40 hertz. And the velocity is equal to n lambda, means 40 into 1 is equal to 40 meter per second. So the amplitude will be 1 meter, frequency will be 40 hertz, wavelength will be 1 meter, and the velocity we are getting 40 meter per second. So a stretched sonometer wire is in unison with a tuning fork. So let initially the frequency of wire and frequency of tuning fork are equal. When the length is increases by 0.4 per 4%, so L2 is equal to L1 plus 4% of L1. So number of beats heard, that means N1 minus N2 is 6 beats per second. Find the frequency of the fork. We are supposed to find out the initial frequency. So L2 can be calculated as L2 is equal to L1 plus 4 divided by 100 L1. So L1 plus 0.04 L1. So L1 will get common 1.004. So that is 1.04 L1, that is L2. So we have the equation n is inversely proportional to L. This is the law of length. So by using this law, we can write n1 upon n2 is equal to L2 upon L1. So N1 upon N2 is equal to L1 1.05 upon L1. L1 L1 get cancelled. So N1 is equal to 1.05 N2. So this is your N1. Or so we will going to put this equation here. So N1 minus N2 is equal to 6. So instead of 1.0 N2 minus N2 is equal to 6. So N2 is equal to 1.04 is equal minus 1. So N2 is equal to 0.04 into 6. So N2 is equal to 6 upon 0.04. So this will become 600 upon 4. 4 ones are 4, 250 or 150. So N2 is 150. And from this equation, now we have the value of N2. So N1 minus N2 is equal to 6. So N1 minus 150 is equal to 6. So N1 is equal to 6 plus 150. So it is 156 hertz. So N1 is equal to capital N is equal to 150 hertz. This is the frequency of tuning fork. So thank you student. Thank you very much. I hope you will get it.